Okay, hi and welcome. These are the notes for 6.7, graphing of absolute value equations. So this goes along with the activity we're going to do in class. If you missed the activity, you should be watching these notes. If you want support for the activity, you'll be watching these notes. But either way, you're here, and let's go ahead and get started. Again, we're going to talk about graphing of absolute value equations here. So let's get a couple basic definitions in here. First, a V-shaped graph that points upward or downward is called an absolute value. Again, key concept is V-shaped. So if we see a V-shaped, we pretty much know that they're absolute value for our sessions here. Now what we're going to do is we're going to take this absolute value and we're going to talk about moving it around. So we could plug points in and graph it each time, but there's an association, a pattern because of this translation here. So what we're going to do is we're going to first describe this parent function that I'm speaking from, or this vertex, and you can see that here, that it says the result is a graph of the same shape and size, but in a different position. We're referring to the vertex, but the vertex specifically from the vertex form. Or I'm sorry, let me say that again. Vertex from the parent form. So the simplest function of a family of functions is called the parent form. So this is your parent function right there. Y equals the absolute value of x. It doesn't get any simpler. We can't make the function of an absolute value any simpler than this. We've got a variable, we've got the absolute value operation. Now, this transformation that we speak of back up here, okay, and this vertex that we're talking about come from this basic form. Let me switch my pen here. So once we have this basic form, we're going to move it around. And there's a pattern. If we want to move it horizontally, to the left or to the right, we're going to add or subtract a value inside the absolute value sign. Okay, so you can see here's the x in the parent form. If we add or subtract a value here, it tells us we're going to move left or right. Now be very cautious with this. This is supposed to be a negative to start. So if I put a positive value in here, or if this looks positive in here, let me say it correctly. If this looks positive in here, so if it says x plus a number, it really means that I put a negative number in, because two negatives make a positive. So if it looks positive, we're actually going to do the opposite of what we would think, and we're going to go left. And this sounds silly, but when we see the example, it'll make more sense. Okay, and vice versa. If it looks negative, it means we put a positive value in here, and it's going to go to the right. So just remember, inside the absolute value, the sign tells you to go the opposite direction that you would think. And then you go whatever the units that h would be, whatever value we put in there. Okay. On the outside of the absolute value, we can also add or subtract a number. We'll call that k. Okay. And k then works as we expect it to. Positive values go up, negative values go down. All right. Now, this gives us the ability to move it left, right, up, or down. So we can translate this base parent function, left, right, up or down now. Okay. We can also do a quick change to it. If we make a negative in front of this, or if there's an a value here we're talking about in a little bit, but just introducing the idea of a negative. If there's a negative here, it flips it. So this one moves it left or right if we put it inside the absolute value. If there's a value on the outside, we go up or down, and the negative flips the absolute value. So if it's V-shaped, if it's negative in front, and now it'll be pointed down. Okay, if it's positive, it'll point up. And this is the introduction to what we like to call the vertex form. And we're not going to get heavily into it yet, but this is your introduction. We will know this form, if I can spell form correctly. We will know this form fairly well. And I can make an F-O arm. There it is. There it is. I got it. Okay. So let's take a look at it so that starts to make a little bit more sense, because right now it probably doesn't. One other tidbit before we do this is that a solution, and we've thrown that word around a lot, so far a solution for a system of equations that we've been studying has been a single point. But when we're talking about a solution for a function, what we've been kind of dancing around all year is that this is where it crosses the x-axis, or we've referred to them as x-intercepts. We've been finding them. That's not new to us. We know how to find an x-intercept, right? An x-intercept comes from when we put 0 in for our y-coordinate, and we go and we find whatever value comes out. That's been our x-intercept. Well, guess what? This absolute value symbol, since it's v-shaped, absolute value function, since it's v-shaped, when it crosses the x-axis, can do it once or twice if these happen to cross and touch there. And we'll take a look at that in the activity. We're not going to go into great detail here, though, about that. The activity will do a good job of that. All right. So I've gone ahead and made a table of values for you. I picked -3 through +3. And I'm going to plug them into my parent function, which is just the absolute value of x. So you can see that here, right? Y equals the absolute value of x. So I'm going to plug in different values of x. I'm going to find out what y value comes out. So if I take -3, put it in absolute value, it comes out +3. If I take -2, put it in absolute value, I get +2. So you can see if I plug these values into the parent function, I get these values out. I use those values to graph this absolute value function right here. Okay, this is the parent function. If I draw a little arrow down, that's what this looks like. Okay, the vertex will always be at the origin, and then as I move to the right, 4 again, the parent function, it'll go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And to the left, it'll go up 1, left 1, up 1, left 1, up 1, left 1. That'll always be the shape for the parent function. You can actually memorize the shape easier than it is to plug in the values. I don't really use this table. The only reason I use this table for you, is so that you could see it as I graphed it here. Okay, but once I've got it graphed, this is really easy to memorize. Plot a point at the origin, up 1, over 1, up 1, over 1. You can then do the same thing to the left, up 1, over 1, up 1, over 1. Okay, now this translation part that we've been talking about right here is that we're going to take this function, this basic shape, which is super easy to graph, plot the vertex, and then duplicate up 1, over 1 to the left and up 1, over 1 to the right. And we're going to be able to just move it around using this h and this k value. Now, so far, I'm cramming these notes together, so it doesn't make much sense. Let's do some examples. It'll come up very quickly for you. And again, this is what the activity will have you explore. So I'm going to look at number 1 here. Number 1 is a translation of the parent function. Here I can actually see the parent function, y equals the absolute value of x. But then here's the next part. Here's the translation. This says -4. Which is telling me, because it's on the outside of the absolute value, not on the inside, like this one here. See, this is on the inside in example 2. It's on the outside, so this is telling me that it was, and if I go back to my notes just to let you see it, if it's on the outside, positive goes up, negative goes down of this parent function. So I'm going to do this. I'm going to go back down here. I'm going to write in what the direction's actually telling me to do. It's telling me to go down 4. What does down 4 mean? It means I'm going to plot my vertex down 4. So I'm going down 4 from the origin because that's where the parent function begins. And then I'm going to do that pattern that we see right here, a little bit of the table left. I'm going to do this shape starting here. So I'm going to go up 1, over 1 to the right, plot a point, and then I'm going to repeat that pattern, up 1, over 1, up 1, over 1, up 1, over 1. Okay. This parent function, and I'm going to do it to the left now, this parent function is being duplicated instead of at the origin down 4. So if I plot those points, here's my graph. Oops, a little wiggly, but you get the idea. If I had a ruler on here, I would totally use it. I don't. So there's this change right here. I shifted it over. Shifted it down. It went down 4. I plotted this basic shape from this table that we already said we don't need. We can just memorize this shape. Plot the vertex. Duplicate up 1, over 1, both sides, and I just moved it down 4. That's the translation. I don't need to plot any points for this. I don't need to plug anything in. I know it's the parent function. I know it's a down 4 because of its location. Now let's take and change my pen color really quick. I might change it to, well, use black. That'll work pretty well. And I'm going to do example 2 on here. Okay. Example 2 is in the absolute value. And if we go back to our notes, we can see that in the absolute value, it should be a negative. So I got to remember that. If it's positive, it means I'm actually moving to the left. If it's negative, I'm moving to the right. But that's going to give me a horizontal change. Now I'm going to be able to move this left and right. So I'm looking at it. It says that it's -2. So I'm going to move to the right 2. So I'm going to write that down. Right 2. Okay, so now I'm going to go from the origin, 1, 2 over. Here's my vertex. That's what I moved. And then I'm going to duplicate this pattern I did here. Up 1, over 1, up 1, over 1. And then I'm going to go left 1, over 1, left 1, over 1. And then I'm going to draw my line. See if I can get a little bit better. The right side seems to be more difficult for me. And there's example 2. Okay, you're starting to get it? Just by seeing it, I think it makes a big difference. All right, so let's jump over to example 3. You'll notice in example 3, we have 2 translations. I've got one to the outside of the absolute value, which tells me to move up or down, right? And then I've got one on the inside of the absolute value, which tells me to move left or right. So let's see if we can make sense out of it first. I'll change my color here real quick. So it's a positive, and remember we said it's counterintuitive, so it says that we want to move right, but really that means we're moving left. So I'm going to go left 2, right? That's what that's telling me. And then this one's -5, so I'm going to go down 5. So those are the 2 movements I'm actually doing. Left 2, down 5. And I just drew that in there so you could kind of see it. Okay? So I'm going to go move my vertex, exactly what I just said. I'm going to actually write it in words so you can see it. So I'm going left 2 and down 5. Oops, extra N there. Down 5. So left 2, 1, 2, down 5. 1, 2, 3, 4, 5. So there's my new vertex. I had 2 movements on it. So instead of being at the origin, we've shifted this one down, this one got shifted right, this one got shifted twice, over and down. And now I'm just going to duplicate my pattern. Up 1 over 1, up 1 over 1, up 1 over 1. And so with that 3rd example there, you should be starting to get the concept of what this looks like and what these movements mean. And again, the activity will do this even better. This is just a crash course in the notes in case you happen to miss the activity and or want to get a little head start on it. All right, so if we summarize what we just learned here, we learned that this is called vertex form. Okay, this H value, what it's really telling you, and I haven't said yet, is the X coordinate for wherever your vertex happens to go. Okay, the K coordinate is your Y coordinate for your vertex. So really what we're doing is we're moving the vertex. These are movements specifically to the vertex, and that's what we've been doing this whole time. So just be mindful that this is supposed to be negative, and if it's positive, that means it was a negative number because 2 negatives make a positive. So that's really all you need to know about this. It's pretty easy. Once you see it a few times, you get it. It kind of clicks. Okay, so those are the notes for today. Again, support for the activity we're going to do on Monday. So otherwise, you're doing this as makeup notes.